Hello. This morning I was chasing Bug around the house with this banana and I was saying, stick him up! Stick him up! It was funny. Waiting for a couple more people to join. Hello. Am I a ninja yet? I'll tell you what, yesterday I was taking a break from doing some of the stuff I was doing, and I went out into the backyard and I threw my ninja stars into the tree for about 30 minutes, and it was really fun. One thing I'll tell you though is that if you miss the target and they land someplace else, it's really hard to find. Because I have a bunch of leaves that are, falling from the tree, and I threw the ninja star and it went right into the pile of leaves, and I was like, oh crap. But I found it. Gonna wait about one more minute. I want to do throwing knives next, because I can throw axes. I guess I can throw ninja stars now, but I haven't figured out how to do throwing knives. Wait about one more minute. Have a pretty quick lesson for you today. All right, so I'm going to go ahead and start. Hang on a second. I think I'm streaming right now. I'm not sure. I accidentally closed my YouTube tab, so I'm not sure if I'm actually live streaming right now. Give me a second to open it up. Okay, sorry about that. Still waiting for the page to load. Okay, so I think I'm going to go ahead and get started with the HL students today. So come on. So for the HL students, we are going to learn about something called merge sort. So this is a faster sorting algorithm than the other ones that we've learned about. So we learned about insertion sort, selection sort, bubble sort. this is the fourth sorting algorithm that we're going to learn. And, okay. And it's the fastest one. Okay, so the first thing we need to learn about is the merge method. So the merge method, what it does is it takes two sorted arrays and merges them into a single sorted array. Okay. So let's suppose I have two sorted arrays. So maybe I have, and let's make one of length 4 and the other one of length 5. Okay. And so maybe this one has 3, 7, 15, 18. This one has 1, 8, 11, 20, 21. Something like that. Okay? So what the merge method does is it's going to take these two lists, which are sorted, and it's going to combine them into a single array of size 9. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so how does it do that? What it does is it compares the first method, or that's not the first method, my bad. The first element of each array, and it puts the smaller one into the first slot, or the 0th slot, I should say. Okay, so 1 is less than 3, so it's going to put 1 into the front of the array. Okay, now it's going to compare 3 to 8, and it's going to say, well, 3 is less than 8, so it's going to put 3 next. Okay, then it's going to compare 7 and 8. 7 is smaller, so it's going to put 7 in. Then it's going to compare 8 with 15. 8 is smaller than 15, so it puts 8 there. Compares 11 with 15. 11 is smaller than 15, so it's going to put 11 in. Then it's going to compare 15 with 20. 15 is less than 20, so we put 15 in. 18 is less than 20, so we put 18 in. So you notice that we're completely out of elements in the top array. So all we're doing is feeding in the bottom array. So then we have 20 and 21. Okay? So that's how it works. So the merge method, it takes in two sorted arrays and it merges them into a single sorted array by comparing the front of each array and putting whichever one is bigger or whichever one is smaller into the merged array. Okay? So that's how the merge method works. There are a couple of cases to consider when you guys implement the merge method today. So you have to think about what happens if the two elements compared are equal. Okay, so you got to think about that. So for example, what if you had, I don't know, two arrays where it was like 3, 4, and then 3, 9. So when you're comparing these two, you have to make a decision about if these two are equal, which one am I going to cross out and put into the merged array? Okay, so there's basically three ways you could handle it. You could always take the top number, you could always take the bottom number, or you could just randomly choose one. Okay, so you just have to think about what happens if they're equal. Okay, and what is it going to do? You also have to think about what happens once the one of the arrays runs out. So as we saw in this example, the top array we ran out, we already added all 4 elements to the merged array. And so after that point, once we got all of those in, we could just add element by element of the second array. So you got to think about what happens if one of them runs out. Okay? So that's the merge method. So now we can actually talk about the merge sort algorithm, and it's a recursive algorithm. Okay, so the way that merge sort works is it takes in an array, okay, and what it's going to do is it is going to merge together the merge sort of the front half. So I'll say, 0 to n over 2 minus 1 with the merge sort of the second half. Okay, so that's how it works. So you're basically taking an array, you're splitting it into 2 parts, and you're calling merge sort on those 2 parts. So once you call merge sort on the 2 halves of the array, and you have 2, so basically you're turning the front half of the array into a sorted array and the back half of the array into a sorted array, and then you're merging those together. Okay, so it's recursive because the merge sort algorithm calls the merge sort algorithm on the front half and the back half of the array, and then it merges them together. Okay, you have to consider, so you're calling the merge sort on the front half and the back half, and eventually you're gonna this merge sort is going to call merge sort again, and so the front half gets divided in 2, and then the front half of the front half gets divided in 2, etc. So eventually you're going to divide the array up into pieces where it's just individual elements. Okay, and so that's sort of like the base case, because remember, in recursion you always have to have a base case. You have to say, what are you going to do once you get to the base case? And so the base case would be just an array with a single element. And in that case, you just return that element, because an array is already sorted if it just has one element in it. Okay, so basically, if a dot length is equal to 1, you just return A. Okay. If it's not 1, then we have to split the array in half. Okay. And then merge the front half and the back half, and okay. So this is how merge sort works. One thing you want to think about sort of a fringe case. In this example would be, what if, well, it's not really a fringe case, but you have to think about what should you do if the number of elements of the array is odd. So that middle element, because if the array has an odd number of elements, then you have to figure out what to do with that middle element. Is it going to go in the front half or the back half? So you just gotta, it doesn't matter which half you put it in, you just gotta put it somewhere. So think about if a dot length is odd. Okay, so let's go through an example of how merge sort actually works. Okay, so I'm gonna get an array. I wrote it down yesterday. So 14, 8, 9, 3, 5, 4, 21, 12. Okay, so we want to run merge sort on this array. It has 8 elements. Okay, so what I'm going to do is I'm going to divide it in 2. And I'm going to run merge sort on each half. Okay, so now I'm going to run merge sort on 14, 8, 9, 3. And I'm going to run merge sort on 5, 4, 21, 12. Okay, now this is not the base case. These arrays both have a length that is greater than 1. So I'm going to split the arrays in half and call merge sort on those. So I split this one in half. I split this one in half. So now I have 14, 8. I have the array 9, 3. I have the array 5, 4. I have the array 21, 12. Okay, so I did this and this and this and this. Again, now I have 4 arrays. Each one has length 2. That's not the base case yet, so I have to split them up again. So I split them up. This one becomes 14 and 8. This one becomes 9 and 3. This one becomes 5 and 4. This one becomes 21 and 12. So now what I've done is I've taken an array that started out with 8 elements, and I've broken it down into 8 individual arrays with single elements. Okay, so now I'm at the base case. So once you get to the base case, you know it's sorted. Okay, and so you need to start to merge them back together. Okay, so now I'm gonna so right here we got to the base case. So now what we're going to do is we're going to merge all these back together. So now we have to merge 8 with 14. So I compare 8 to 14, and I say 8 is bigger than, or 8 is smaller than 14. So now I have the array 8, 14. Okay. 9 and 3, I compare them. They become 3 and 9. 5 and 4, I compare them. It becomes 4 and 5. 21 and 12, I compare them. It becomes 12 and 21. Okay? So once you get to that base case, then you start to merge it all together. So now I'm going to merge this one with this one. So doing the merge method for those two, I compare the front to the front. So I get 3. Then that's taken care of. Then I compare 8 with 9. I put 8 in. That one's taken care of. I compare 9 with 14. 9 is taken care of. And then I put 14 in. So now these two have been merged together. Okay. Now I need to merge these two together. So I compare 4 with 12, and I put 4 in the front. I compare 5 with 12. I put 5 in the front. And then this array is empty, so I just tack this one onto the end. Okay? So now I've merged those two. So now I have these two sorted arrays, and now I need to merge them together. Okay? So comparing 3 with 4, I put 3 in front. Comparing 4 with 8, I put 4 in front. Comparing 8 with 5, I put 5 in front. Comparing 8 with 12, I put 8 in front. Comparing 9 with 12, I put 9 in front. Comparing 14 with 12, I put 12 in front. Comparing 14 with 21, I put 14 in front. And then 21. Okay? So basically this algorithm, it's a recursive algorithm. It's a divide and conquer algorithm. So what it does is it takes the array, it breaks it in half, okay? And it keeps doing that. Breaks them in half, breaks them in half, breaks them in half, until it gets to individual elements. And then it uses the merge method to rebuild the array. All right? And so because it uses this sort of divide and conquer approach, it ends up being faster than selection sort, insertion sort, and bubble sort. Okay? So you're going to implement the merge sort. Okay? So I taught you about the base case. Yeah. So that's how you do it. All right, so now I'm going to go to my SL lesson. So I need to share my desktop, which is this one. Okay. So sort of the final piece that I want you to know about for the graphics that we've been studying is there's just a couple more methods. So maybe on Monday I'll do draw image or something like that, but I'm not really terribly interested in that one. There is a drawstring method in the graphics class, drawstring. And so that's going to add text. Okay? That's going to add text to your graphic. Okay? So I have some code here. And once again, I have overwritten the paint component method. And you can see that I have g.drawstring f. Okay. 0, 100. So those are the coordinates where I'm going to put the letter F. Now, any graphic, it has a font. So you need to set the font of the graphic, okay, before you draw your string. All right, so you use the set font method. So there's a set font method. Where is it? Set font. Okay, and that's going to, what that's going to do is it's going to make sure that when you put in the string, that it's in the font that you want it to be in. So notice how the set font method takes in a font object. Okay, so there's a class called font. Here it is. If you want to use the class font, you have to import java.awt.font. And the main thing about font is the constructor. So this is the constructor that we are going to use. Okay, so the constructor takes 3 arguments. The first is the name of the font. The second is the style of the font, and when I say style of the font, I mean bold or italic or regular, okay? So that would be plain. And then the size of the font, how many points is it? Okay, so going back to my code, you can see that I set the font to a new font. So right here I have the constructor for the font class. Okay, and the font is, I'm going to be using, is called Arial, which I'm sure you've seen before. I'm going to make the font plain, not bold or italic, and 40 points. So that means that the height is 40 pixels. Okay. One thing you got to be careful about, if your computer does not have the Arial font, then that's going to run an error. So there is a method in the font class, or maybe it's not the font class, in the graphics class. There is a method, I'll look it up a little bit later, but there's a method that will actually tell you all the different fonts that are in your system, so that you can choose a font that your system actually has. But I'm guessing most of our computers have the same fonts, so we can just use Arial. Okay. One of the things about the fonts that's different from shapes. So let's say I draw a string F at 0, 0. Okay, so I'm going to compile that. And I'm going to run it. And you can't see anything. There is no F. Okay, why is that? Well, that is because in contrast to shapes, when you give the coordinates of a shape, this coordinate is for the top left-hand corner. Okay, but for a font, it is for the bottom left-hand corner. So this is the coordinates of the bottom left corner of the string. Okay, so what's happening here is that the F is, here's 0, 0 in the upper left-hand corner, and the F is like up here, so we can't see it. All right, so maybe I change the Y coordinate and I move it down. It's a 40-point font, so maybe if I move it down 40, it should just barely fit in the window. So let's try that. So I shifted the F down by 40 pixels. Oops, I don't think I, let's see. So there we go. So I shifted the F down and now we can see it. All right, so that's a little bit different from shapes. Shapes, the coordinates are given by the upper left-hand corner. For fonts, it's the lower left-hand corner. So now I have the F in there. Okay. So the purpose of teaching you about fonts is if you're in SL, you're writing this program that's going to basically graph lines, and I want you to label the axes. Okay, so you're going to have to figure out where to put the Y and the X so that it displays X and Y axes, and it also draws the axes themselves, and it draws the line that the user inputs. Okay, so that's my lesson for today, and I will see you in the Zoom room.